Hello all, I'm Dr. Prabhas Sanjanbal. In today's class, we'll discuss about the pumping lemma of context-free language. We have already discussed about the pumping lemma of a regular language in some previous classes, but in this today's class, we'll discuss about the pumping lemma of context-free language. It is the procedure of pumping lemma of context-free language is completely similar to the procedure of pumping lemma of regular language. Okay, see what is the meaning. So why we will use pumping lemma of context-free language? The definition here, it is generally used to prove that a language L, it is generally used to prove that a language L is not context-free. It's not context-free. We'll also use contradiction method. Contradiction method to prove that a language is context free or not. Okay, so we'll also use pigeonhole principle. Pigeonhole principle will similarly use in this pumping lemma of context free language. Okay, so now we'll see the definition of pumping lemma of context free language. Okay, if L is context free, if a language L is context free language, then L has a pumping length P. Okay, later we'll discuss about what is the meaning of pumping length. Okay, don't worry. So if a language L is context free language, then the language L has pumping length P such that any string S means this string must belongs to this L. This string must belongs to this L. Okay, such that any string S where S means length of S, where length of S must be greater or equals to P. P means pumping length, and the string S is divided into 5 parts, and the string S is divided into 5 pairs, that is what U, V, X, Y, Z. Then the following conditions must be true. Okay, these are the following conditions. See here, in case of pumping, I'm just comparing pumping lemma of regular language and context free language. I'm just comparing. See here, in case of pumping lemma of regular language, we just divide the string S into 3 parts. Let it is X, Y, Z or U, V, W in case of regular language. But in case of context free language, the string S is divided into 5 parts: U, V, X, Y, Z. Okay, the string S is divided into 5 parts: U, V, X, Y, Z. This is for context free language. But in case of regular language, see here, regular language, S is divided into 3 parts: U, V, W. Okay, U, V, W. Remember, in case of regular language, means pumping lemma of regular language, V must be a self loop. But in case of context free language, V and Y must be a self loop. Means there are 2 self loops in case of context free language. But in case of regular language, there is generally 1 self loop. This is the difference between the regular language and context free language. Means pumping lemma of regular language and context free language. Okay, so now we'll see the conditions. What are the conditions for pumping lemma of context free language? See here, U, V, I, X, Y, I, Z belongs to L for all I is greater or equals to 1. Means for all I value, means I value should be greater or equals to 1. What is the second condition? Length of V and Y, length of v and y must be greater or equal to 1. Then what is the third point? Third point, length of vxy, length of this one vxy must be less or equals to p. P means pumping length p. P means what? Pumping length p. So these are the three conditions. Based on the three conditions, we will prove that a language L is not context free. Okay. Again, I am telling, if L is a context free language, then L has a pumping length p such that any string S, means S belongs to this L. Any string S where length of S must be greater or equal to p means pumping length, and is divided into 5 parts, that is u, v, x, y, z. Then the following conditions must be true. Okay, these are the following conditions: u, vi, x, yi, z belongs to L, length of vy greater or equals to 1, and length of vxy less or equals to 5. Okay, so now we'll see the algorithm. The algorithm is completely similar to pumping lemma of regular language, completely similar. Okay, so now we'll see. See the algorithm. This is the algorithm for pumping lemma of context free language. What are the algorithms? Say the first step, let us assume that L is context free. Let us assume that the language L is context free. Let us assume that the language L is context free. What is the second point? If L is context free, then it has a pumping length, that is p, because this is the definition. This is the definition. If L is a context free language, then it has a pumping length. This is the definition of pumping lemma of context free language. Okay, this is the second step. What is the third step? Select a string S. Select a string S from L. Select a string S from L, and its length must be greater or equals to p, means pumping length. Okay. What is the fourth step? The fourth step is here. Divide the string S into 5 parts. Divide the string S into 5 parts, that is u, v, x, y, z. Divide the string S into 5 parts, that is u, v, x, y, z. Where v and y must be a self loop. Where v and y must be a self loop. Okay. What is the fifth step? Fifth step is here. If u, vi, x, yi, z belongs to L for all I value. For all I value means I value is greater or equals to 1. For all I value, then L is context free language. Then L is context free language. If u, vi, x, yi, z does not belongs to L for any I value, does not satisfy, then L is context free language. These are the algorithms. Now we'll see the example. See example. Now we'll see the example. See here. Let language L prove that language L equals to a to the power n, b to the power n, c to the power n is greater or equals to 1 is not context free. Okay. Prove that the language L equals to a to the power n, b to the power n, c to the power n such that n is greater or equals to 1 is not context free. Okay. Now how to prove here? What is the first step? The first step is here. Let us assume that L is context free. L is context free. Now we'll assume first step, let L is context free. What is the second point? If L is context free, then it has a pumping length P. Okay. Let the pumping length, since L is context free, it has a pumping length P. Let the pumping length P equals to, here I am taking 4. Let pumping length P equals to 4. What is the third step? Select a string S. Select a string S from L. Select a string S from L and its length must be greater or equals to P. Let I am selecting a string A to the power based on the pumping length. See here, select a string let it is S equal to A to the power P, B to the power P, C to the power P. Let I am selecting a string A to the power P, B to the power P, C to the power P and its length. What is the P value? Here P value equals to 4. Means A to the power 4, B to the power 4, C to the power 4 and its length is around 12. Its length equals to 12 and its length is must be greater or equals to what? Pumping length P. P means 4. Okay. So this string length, this is my S. The string length is greater or equals to its pumping length. What is the fourth step? Your fourth step is divide the string S into 5 parts. Now we'll divide S into 5 parts. So S equals to here A to the power 4, B to the power 4, C to the power 4. Divide this string into 5 parts. What? U, V, W, X, Y. Now we'll divide this string into 5 parts, where V and X must be a self loop. Okay. See. Now we'll check. What? A to the power 4, B to the power, C to the power 4. See. A, 4 H's, then 4 B's, then 4 C's. Now we'll divide this string S into 5 parts, means U, V, W, X, Y. But divide the string into 5 parts, but based on the conditions. What? The condition is here. We have already discussed in the upper part. Vy, the second condition, and third condition. Vy must be greater or equals to 1. Vxy, length of Vxy must be less or equals to its length P. Okay. So now we'll divide. Vxy, its length must be less or equals to P. P means here P length of P equals to 4. So let's I'm taking this one is V, this one is X, this one is Y, and this part is Z, and this part is U. U, V, X, this is Y, this is Z. Okay. So we have completely divided. So that means we can write here U equals to triple A, V equals to what? Single A, X equals to BB, Y equals to single B, Z equals to B4C. Okay, so this is in this case we have already divided the string into 5 parts. Now we'll check for all I values. Okay, here if I value equals to 1, if I value equals to 1, see here you can see length of Vy must be greater or equals to n. Length of Vy means AB, its length is equals to 2 is greater or equals to 1, and length of Vxy means 1, 2, this is 1 means 4. Length of Vxy means A, B, B, B is equals to 4. 4 is less or equals to P means 4. Okay. I value equals to 1. If I value equals to 1, now I'll find what? U, V1, X, Y1, Z. U means here triple A, V means 1A, X means 2B, Y means 1B, Z means B 4C, B 4C. So here this one contains 4B, sorry 4A, 4B and 4C. So it belongs to L. It belongs to L. Now similarly I'll check for I value equals to 2, U, V2, X, Y2, Z. U means triple A, V2 means 2A, X means 2B, Y square means 2B, Z means B 4C. Okay, so it contains 5A, 5B, 4C. So it means for I value equals to, the string S does not belongs to L. Okay, so if for any I value, any string does not belongs to L, that means the language is not context free. So hence the language L equals to A to the power n, B to the power n, C to the power n, such that n is greater or equals to 1, it's not context free. In this way, we can prove that a language is context free or not using pumping lemma. So this is the end of pumping lemma of context free language, and it is the end of entire context free language and push down automata part. In the next class, we will discuss about the Turing machine and recursive enumerable language. Okay, thanks for watching.